just a reminder before we get into our next presenter that if you want to talk about any of this stuff that we're talking about today, go on your social media. The hashtag is APIsecure 2023. We're watching there, and we can hook you up with some of the contact information of any of our presenters who are looking to have additional discussions today. And so, really excited to get anybody and everyone talking about this. And so, for the last presentation here in this stream and Blue Stream today, we have Meenakshi Kaushik, Leader Project Manager at Cisco, here to talk to us about detecting sensitive data passing through APIs, regular expression versus ML RNN techniques. And so a whole lot to take in there. I know a lot of people are very curious about how to detect what type of data is actually passing through the API so that they can make determinations as to what to block. So over to you, Meenakshi.
Thank you so much, Trish. Let me just share my slides and just let me know if you can see it in the full screen mode. It's loading. Can you? Trish?
Absolutely.
Did I
Yep, we
lose
can see it.
everybody?
Great.
Okay,
No, you're good.
perfect.
You're good.
Yeah. Thank you so much, Trish. And hello, everyone. Welcome. And thank you for staying back to the last session of the conference. My name is Meenakshi Kaushik, as it was said in the introduction. And when ChatGPT came along, not the 4, but the 3, somewhere late last year, I was also in the phase where I was getting more and more deeper into the API. And so I was thinking, how can we detect sensitive data passing through APIs? And with the help of ChatGPT, I was able to do all this analysis, which I'm sharing, in like 3 or 4 hours max. And I'm just going to take you along the journey about why. So let me just talk a little bit about the agenda. I'm going to talk about what sensitive data is, why you should care about sensitive data flowing through the APIs, and what if you had a single regular expression to detect sensitive data, and what are the challenges there. And so what are then your options? Can we use advanced regular expression? Can we use machine learning? And then just compare and contrast those 2 methods, and then finally provide conclusion. So let's start by looking at why it is important to detect sensitive data flowing through the APIs. So APIs are the window through which an enterprise exposes their products. It's an explicit open window where either the APIs are for user interfaces, or APIs are direct APIs which you connect to look at the application. Like, for example, you could go to Google and do some image recognition, something like that. And obviously, there are other elements in the application stack, but the first easiest way, if you wanted to enter sensitive data into your application stack, it would be through the API. So it's the first initial place, and hence it is important to detect as early as possible, shift left as possible. So you want to detect sensitive data in the API as it flows through it. And that's really what this slide is trying to talk about, is that you're trying to shift left your security by detecting sensitive data as at the shift left. So you can see the blue arrows where the data flows in, and then ultimately it goes into your databases. So if you can detect it in flight, then you can also provide correlation of the flight data with something which is at rest. And let's say a data breach happens, then you are able to also correlate the data. So there are many advantages to doing shift left. And when we look at the recent attack history, it's not an exhaustive list, it's an example list. We can see that the data breaches really are important for organization to pay attention to, because the cost of data breach is pretty high. And obviously API data in the API is the window. So yes, you want to prevent data breaches, but the other thing is that for many organizations, you have to comply with security standards, and rightfully so that when you take the data from your customers, you want to make sure that you're following correct standards for handling the security data all the way through. And so what are the examples of sensitive data? And this is not an exhaustive list, just to give an idea of what I'm talking about. It's some personal information like name, address, phone number, financial information, health information, some credentials, geolocation information, legal information, PII data, and many others in the list. So how are we going to evaluate the solution that I'm going to talk about? So the two use cases which I hear from the enterprises, from customers, what they really want to do is that, yes, you detect the sensitive data based on what is considered standard best practices like PII data, etc. But also the organizations want to be able to provide what sensitive data looks like to them. So for example, in different countries, PII means different things. Maybe it's not social security number, but it is some other identifier which is more important. So they may also want to make sure that we are able to detect sensitive data based on user supplied input. So it's standard best practices as well as sensitive user supplied input. And so as I walk through these different techniques, we would look at how easy it is to do something which is well known versus something which we have to customize using regular expressions. So what's the problem if you had a very simple regular expression? So before I go a little bit deeper into all the solution, I just want to say that I'm making a lot of assumptions. And so one of the assumptions which I'm making is that I'm looking at sensitive data flowing through open APIs. So assuming that only that is one thing. And then, of course, data can be in many formats in Open API, but I'm going to pick up an easiest format, which is the JSON format. And obviously, whatever we look at it here, it is applicable in other format scenarios. The one thing, and the other thing is when we are looking at sensitive data, I'm only looking at textual data. For example, in the key value pair of JSON, you could be sending, for example, audio file or a video file. So this is not going to go inside that audio or the video file for at least the ones which I'm talking about to detect sensitive data. So this is text value data which are flowing through the JSON format. So some of the scenarios, if you had a very simple expression, is that JSON objects are very structured. So that is a very good thing. It's actually very easy to look at it. There is a specific syntax to it, and that makes searching very easy. But even in that scenarios, a simple regular expression would not work because first there can be multiple regular expressions on each line of your JSON objects. And then there can be dynamic key names, which you may not know in advance. So depending on the type of regular expression that you have, you may not know that. There can be nested JSON objects. There can be JSON objects with arrays. There can be malformed JSON or missing keys. So even the regular expression pattern matching has to ensure that it is able to look at all of these scenarios. And I just... Again, as I mentioned, I was using ChatGPT. So I just quickly asked ChatGPT, give me an example of all of this. And so here is an example where this is all the sensitive data. This is an example of a phone number is a nested example under user. So this is like something like a nested JSON object, what we are talking about. Some JSON objects have arrays. So for example, items has this list of items in an array. Unknown key is this unknown key, and then missing key is not present in this JSON structure. So something like that, like let's say you have something like that and you want to detect sensitive data at each of these levels, what would you do? So one way to do it is that you expand on your advanced regular expression. And we're going to walk through this collab code, which is pretty simple. I generated it through ChatGPT. I did have to prompt a couple of things, but which I'll just share. And the challenge with this, as we will see as we look at the code, is that its complexity increases as you want to search more and more regular expressions. So it's like an O(n) squared kind of complexity of the runtime complexity of this. And so for small things, yes, you can use it in your code, no big deal. But as the search list gets large, this may not be really the best way to go. So let's just quickly go to my collab. And this is the regular expression sensitive data. And so I just so this let's say, as I was saying, this is like kind of the list you would add to your sensitive data types as you're searching for regular expression. The code is pretty straightforward. You do a certain thing, whether for example you have this normal JSON array, or if it is a list. And so when the first time I prompted ChatGPT, it forgot about the list, but then I was able to like reprompt and get the entire thing. And then essentially, then you're just doing a very simple regular expression matching. And then if you had some object like this, and if I were to run the code, it's very quick to run. And then it will, yes, it will like, as you can see here, for example, it will be able to mask all the sensitive data. So that it's pretty straightforward, except because it is in a loop, as you can see. So because it is in this loop of for key value JSON items, and these are the items which you continuously add into your regular expression list, as this grows, your runtime complexity increases. So at some point, this may not be like an enterprise grade thing that you may want to use. So then what are the other options? So I'm going to go back to my slides. Just give me a second. So then we can look at machine learning techniques, natural language processing techniques. Obviously, now with ChatGPT 4 coming in, and there has been existing, but there are language techniques which are pretty impressive. But as I was pointing out, for us, JSON is a very structured thing. It is not too complicated, and so it depends. We don't have to go with a very sophisticated model. We can just go with a long short-term memory model, and we should be able to very quickly build something which is pretty good. So let's try to train a machine learning model to do the same thing. Obviously, when we are training the machine learning model, the first thing that you need is data. And I didn't have the data. So I just asked ChatGPT, oh, can I use some library to generate the data? So I'm using Faker, a library which makes it very easy for you to generate fake JSON objects, and you can stuff it with whatever you want. And so that's great, because once I have the training data and I can label the data as, oh, sensitive or not sensitive, then I can build this LSTM classification model, which can classify anytime it sees the JSON object and decide whether it is sensitive or not sensitive. And so this is a very quick code that I was able to develop, and it doesn't have the issue because you build the model, and then during the prediction phase, you're just using that model, which size is also not pretty large. So essentially, it doesn't suffer the same problem of the complexity, the runtime complexity, which was there in the regular expression. But then what about when you have to add custom sensitive data? So this is like adding another input into your machine learning model. So when you have to add another input into the custom sensitive data, then you'll have to retrain your model for that custom sensitive data. It's not a big deal if you have a machine learning pipeline, but if you didn't have a machine learning pipeline, then for every input which the customer says, oh, I have this regular expression, it might be difficult for you to generate a new model for it. Now, the second question is, before we jump into the code, is that, do you really have to train the model yourself? The answer is no. There are Hugging Face, for example, has a PII library which you can use, or you can even just fine tune on top of ChatGPT, which is a natural language processing model, and BERT, which for me, I think it's overkill, but you could just do a fine tuning on top of it, or you can do some kind of transfer learning or data augmentation and ensemble model techniques. These two techniques to not really generate a new model per se for every time there is a change in the sensitive data. So with that, let's start by taking a look at the RNN LSTM model. So as I said, I'm going to use Faker to generate fake data. And when we look at this Faker generator, I'm just generating two kinds of data, one which is sensitive data and one which is not sensitive data, so that I have some representation of both kinds of data for doing classification. And as you can see, I generated 1,000 objects with some fake credit card number, fake security number, and then some which are without the sensitive data, so that I have some representation and I know the exact label. So I'm just able to label it, and then put it in a way the machine learning model can recognize. Now, one thing you might say is that, oh, but you are not doing any regular expression. So the thing is that the Faker library is not able to generate data just directly based on regular expression, but that's not a big issue, because before a Faker library, you can create a random number generator and then generate data based on the new customized regular expression which your customer may ask you to. So that's a very simple addition to this code. And then once I have the data, and this is where I talked about fine tuning or using some other library where you don't have to tokenize it. Right now, my tokenizer is only based on the tokens which are generated in the fake data, but you can have a better tokenizer, for example, and then just pad the sequence, regular stuff for LSTM, and then put the labels in the format that you want. And then now you're just I'm generating a very simple model of LSTM, a two-layer LSTM model followed by a dense model, and just compile it. And after I compile it, and then I'm trying to just check for a sequence. So I can run it, but what you can also see in this is that I get a pretty high accuracy. Okay, so and that's because I have very small training data set. I get close to 1 accuracy, and I'm easily able to predict sensitive data. I easily able to classify the sensitive data. And there are certain mitigation techniques that I talked about, which you can do so that you don't have to retrain the model completely for every time your customer asks for some customized sensitive data projections. So this will take a little bit of time as it is running through the epochs. So what I'll do is I'll complete the conclusion and then come back and just show you the result. I think I'm only running 10 epochs. So I'm not even running that long to get this data. So as you can see, the accuracy is pretty high, but remember, like, I have such a small training data set, maybe it's even overfitting. So of course you might have to play around a little bit with the hyperparameters that I'm using. But in general, this thing should pretty much work. And then once I have that, then I should be able to very quickly predict, right? So if I gave the sensitive data here, then it should be able to classify and say, yeah, it is sensitive data. I figured this out. So with that, I'm going to conclude so the conclusion really is that, you can make regular expressions a little bit more advanced, and that will be able to detect sensitive data and might work for a subset of collection of regular expression if it doesn't go too high. But as the kinds of regular expressions that you want to detect that go higher and higher, you're going to suffer with the time response with the customer. So that's just the runtime complexity of that. So machine learning problem can reduce that runtime complexity. Now, there are additional techniques that you can use so that you don't have to rebuild the model. And even if you do, these days, it is very easy to push new models. So either ways, either you can have an efficient machine learning pipeline, or you can have ability where you're using ensemble models or data augmentation techniques to even mitigate that. And obviously, I mean, I don't have to say it. Everybody's aware of 3. Everybody's aware of 4. ChatGPT 4. If I had time and ChatGPT 4 was readily available, I would have actually built the UI in front very quickly. But it was very quick for me to explore all of this with the help of ChatGPT. With that, I come to the conclusion of my talk. I'm going to stop presenting.
Awesome, Meenakshi. Thank you so much for presenting that. I know, so as I mentioned at the very beginning, I think trying to identify these little factors would take human analysts so long. So as you're going through these recursive models, how much by volume data did you really find that you needed as a minimum to be able to baseline that kind of machine learning?
So as I said in my talk, I actually had no data. And I was like, where would I find the data? Because you really do need the real data. But the good thing is there is this library called Faker. And you can fake it to whatever data you want to construct. And so straightforward. and you can generate any kind of data. So
Hmm.
one problem with getting live customer data is obviously security concerns. Do you have sufficient, access? And uh,
Hmm.
I find Faker to be very useful in
Hmm.
building in such scenarios, especially the case of sensitive data. Yeah, as long as you know what
Right.
it looks like, right? As long as it look like
Yeah, for
it.
sure. I was really more asking, for the teams that do have already kind of
Oh,
dummy data
yeah.
internally, how much data did you run through the models?
Oh, okay. So the larger the data, the better the model will be, and it will be less likely to overfit as well. So
Hmm.
the rule of the thumb is I just use 2,000 inputs, which is not sufficient. If you had a volume, like if you had like 100,000 of those things, it'll definitely be more. But it's not just just not the volume, but it is also for every different kind of expression in each of those subsections of the kind of regular expression that you want to do. You need to have sufficient quantity in each one of those, otherwise it will overfit on the other, and then the one which you only had one like samples, then in that case it will not detect, and your
Mhm.
accuracy is so high you will not be able to figure out why for that regular expression it did. So it's like
Right.
for every regular type of expression you want, you have to have equal quantity of the sample sizes,
Yeah.
and ideally close to equal quantity of sample sizes. Yeah, and
Okay.
then of
And in
course
terms of diversity of calls and diversity of
exactly. Yeah.
regexes, okay. And so a more less so on the volume of it, but more on the diversity of the different types of calls. That's
Yes.
really interesting because I think that's something that we forget to include. So
Yeah.
in SOC practices, as you're building out, the regex for the detection of certain types of activity, you're using a very specific type of log. You're removing the opportunity for other logs to put it in. But I guess what you're saying is, with the introduction of machine learning and AI, you don't need to remove that, and in fact, it helps it become better.
Exactly, because see, this is the same issue which we have with machine learning model, that sometimes it penalizes a subsection of the group, which is
Mm,
maybe it penalizes women in certain cases because they don't have sufficient women data. So when they
right.
build the model, the accuracy is high, but the thing
Hmm.
is that there were so few samples of women thing that even if it was wrong in predicting something like that, the accuracy is so high you wouldn't know it. So you have to have equal representation of every section of the society, in this case every section of your regular expression, to for it to the machine learning model to equally represent
Hmm.
the final analysis. Yes.
No, that makes total sense, and it's certainly something that we're learning in other applications of machine learning as well, but certainly in the cybersecurity perspective of it as well. Something that we learned yesterday in our keynote speaker at the end of the day was the risk that we run of our security technologies feeding us what we're referred to as false negatives. So the false sense of security that something isn't happening. To what degree could using and implementing machine learning and AI, as you mentioned here, could that eliminate more and more about that false negative narrative that we hear so much about?
It's a great question. I don't think that there is just that one way where you can check and say, "Oh, I have eliminated. This is good now." You have to do it across. It's a continuous spectrum of evaluation. So one
Mm,
good evaluation, of course, is that you start with your data as the first question that you asked, right? Is the representation of the data is good? Because if the representation of the data is good, then the second thing happens is that the model accuracy is a good prediction of how accurate your model is. So that tells you how much false positive or false negative there are, in at least at the onset. But then what you also need to do is when you put the model into the live system and start making prediction, what you should also look at is that can you then ask the question of the interpretability. Tell me why you said something. So all these models should be interpretable. So you should be able to ask the question of why did you say it was yes. So then it should be able to map and say I said this yes because I matched the regular expression y for this
mm,
input. So that's the other check that you have to do all the time. And then and that's because even though your initial data set may be good, but in real world those data sets may be constantly changing. You may not have accounted for different ways in people use that regular expression in your input, for example. So the first step is make sure the data is equally represented. Then second is look at the accuracy, which will tell you how accurately it is representing the data. Put it into production, but for every time you serve the customer, in the audit logs, find out what it matched against, and then you have that evaluation to see, did it match right, like did it match the right regular expression to give the user that input, right? Like, for example, if it's matching telephone number, it should match the regular expression of your telephone number in the input data to make sure that your model set is interpreting correctly in production. And then also monitor for the fact of data drift. You may have started with training set X, assumption of training set X, but when you put it in live system, people may be sending you training set Y. And so then you have to train the model that way. So it has to be this whole closed loop to ensure that you're not over trusting your uh, models, and then you're putting guardrails in place to make sure that it is doing what you would want it to do. And I think the final step, which I like, which Google has created, they call it a model card, which is like a specification. So when you give the model to somebody, you tell them the boundaries under which it is correct. So I only am looking at telephone number, regular expression, social security number, and X, and it will give you only the accuracy of 98%. So if you're going to ask the question 100 times, 2 times it will be false, right? So that kind of data should be put on set, so the user is aware of the boundaries under which it was trained. And if it is using it beyond that scope, then it's not going to give the desired results.
Interesting. It's such an interesting problem because from a blue team perspective, one of the biggest risks, as we learned in some of the previous talks, was the threat of insider, the threat of individuals inside leveraging outbound API for the extraction of data, perhaps. And um, in my experience, that was a use case that no one had even thought of. In terms of maliciously leveraging APIs to do something harmful to an organization, was to use it to exfiltrate data. And one of the biggest question marks was, how do we then identify that, because it may be obfuscated. But using this recursive network, as you're describing, could be a way of beyond the regex that we're all used to, identify some key key phrases or some key sequencing that may indicate some kind of critical data. So that's absolutely fascinating. And sort of my last question, unless anybody else in the comments has questions about this, I know it was you've certainly left me a lot to think about in terms of application in my organization. But when you think about this kind of work, the work that you're doing right now from a security team perspective, I would imagine it would need to be something that either a more advanced analyst would need to do, or perhaps the device team. For those who are listening, who are thinking about implementing these kinds of advanced techniques in detection, how do you organize something like this in a security team? Does this belong to the security operations? Does this belong to the content developers who were previously writing the regexes? Does this belong to the devs or the device or technology managers and engineers? Where do you think this would land?
Interestingly enough, it could fall in different user persona, depending on how the organization is structured. So if you look at it, the way the APIs flow into the organization is using an API gateway. And somebody may say that, okay, this is like a firewall, in front of a gateway where you're looking at sensitive data. So that could be one place. But if you were like responsible for data, all the databases, right? All the data at rest, then before you put your data into your database, you want to be 100% sure that it is like you've detected the sensitive data, you've done whatever needs to be done, either while you're putting it into the database or while things are coming out of the database. So it could like even belong in like a database kind of a team, where in front of that you're detecting sensitive data at the right spot. And then the third, where I actually work in this team, where you could have a entire, you're looking at a cloud native security, and now
Mm-hmm.
you're making correlations. You're trying to figure out how data is flowing through the organization, but more importantly, can you look at the data in the API and then are able to map the entire flow? Okay,
Mm-hmm.
this data went into six, like, okay, it's like Meenakshi's data, or let's say Trish's data. And now I know that this data went into this database, and then they can make the correlation between all different kinds of databases where your data is. So tomorrow, if a breach happens, which it shouldn't, but if it did, you're
Mm-hmm.
able to map what to shut down. What should I quickly? What is my what is my first thing I should do? What is my
Mm-hmm.
first step of action, mitigation, which I can do, because I know which APIs have been adding this data and which applications belong to those APIs. So let's shut all that down. So that way I've done the first level of attack before I come up with a systematic way of how my organization handles data breaches, because they happen too frequently, unfortunately. Yeah.
Sadly, yes, I couldn't agree
Yeah.
more. But it's really interesting because we keep talking about the application of AI and specifically Chat GPT in security, and we talk about writing malware and writing. But one of the things that we haven't talked about is how we can use it to assess and analyze big loads of data in order to develop detection capabilities. So sorry,
Yeah,
I've got a co-host here,
yeah,
but
fine. Yeah.
but thank you so much for your chat. I'm just gonna really quickly check back in our chat to see if there's been any questions. So far so good. Really eye opening, and I'm actually quite excited to give it a shot myself. And so when ChatGPT 4 comes out and they start asking for that paid subscription for additional compute, that's absolutely something there, because as a security practitioner, as a blue teamer specifically, I'm sitting here and I'm like, well, how do I use it? Like, I
Yeah.
understand and I appreciate how offensively you can use it, but how does this apply to me? And so really couldn't be more grateful for the presentation, and actually really cool, and happy Women's Month to you as well, to see other highly technical women in the industry and in the field. So really appreciate it. So thank you so much for your time. Really appreciate it.